Hello friends, this video is going to be on end behaviors. So let's take a look at question number 1. Graph number 1 is headed downhill on the left and uphill on the right. So we are going to say that the limit of f of x on the left hand side is going down towards negative infinity, and the limit of f of x on the right hand side is going up towards positive infinity. And that is it. Question number 2. This is going down towards negative infinity. This is also going down towards negative infinity. So we're going to say the limit of f of x as x moves to the left is going down, and the limit of f of x as x moves to the right is also going down. Okay, when we don't have a picture, the only thing we want to look at is, when it's in standard form, the highest power and the sign. And we have an odd power, so that tells me that the ends have to be going in different directions. And we have a negative in front. That means that this graph is going to take on a shape similar to this. So it's going to be going up on the left and down on the right. So I'm going to say the limit of f of x as x moves towards the left, the graph is moving up. And the limit of f of x as x moves to the right is moving down. Question 4, I am only going to look at my power, and I'm going to look at my sign in front. So I notice that my power is an even number. That means the ends have to be going in the same direction. So they're either both going to go up or they're both going to go down. And because this is positive, they are both going to go up. So my graph is going to look mostly like this. The ends, not the middle, but the ends. So I'm going to say the limit of f of x as x moves to the left, the graph is moving up towards infinity. And the limit of f of x as x moves to the right is also moving up towards infinity. Question 5, I am only interested in the lead power. I am only interested in the lead sign. The lead power is even. I don't know what my problem is with spelling that word today. Is even. That means that the ends are going to be going in the same direction. And this is a positive number. Is this different than that one? Oh, it is. So this is positive. So again, it's going to take on a shape most like this. The ends anyway. Not the middle, but the ends. And so I'm going to say the limit of f of x as x moves to the left, the graph will be going up. And the limit of f of x as x moves to the right is also moving up. Okay. Question 6. I am only interested in the power of the lead and the sign of the lead. The power of the lead is even. If the power of the lead is even, that means the ends are going to be going in the same direction. If the sign in front is negative, that means they're going to be going down. So it's going to most look like this. So we're going to say the limit of f of x. As x moves to the left, the graph is also moving down. And the limit of f of x. As x moves to the right, the graph is still moving down. This is just to point out to you that it doesn't matter what, it does not matter what is happening out here. I am only interested in the power and the sign of the leader. That other stuff is irrelevant. So I only want to know about these things. This is even. That means that they're going to be moving in the same direction. And this is negative. That means they're both going to be pointing down. So I'm going to say the limit of f of x as x approaches negative infinity. In other words, as x moves to the left, the graph is also going down. And the limit of f of x as x is moving to the right, the graph is still moving down. Okay, so sometimes they're not as pretty, but that's workable. You could multiply these all together. It would take you probably an hour and you'd probably not get it correct because there's just way too many places to make a mistake. But we're going to find out our powers. If we multiplied all this together, our lead power would be 2, 3, 2, and 1. So our lead power would be 5, 6, 7, 8. Our lead power would be x to the 8th. And the number in front would be the number 4. So no matter what this begins, no matter what this comes out to be as you multiply it all together, it's going to be 4x to the 8th. Again, I just added the pink powers together and got 8. 2 plus 3 is 5, plus 2 more is 7, plus 1 more is 8. And then I wrote down the number that's in front. So the number that's in front is a positive number. So if it is even, they're going to be going in the same direction. And if it is positive, it is going to be pointed up. So that is going to be the limit of f of x as x moves to the left is equal to infinity, and the limit of f of x as x moves to the right is still going to be moving up. So when it's in factored form, that's a power of 1. I'm going to count my powers. I have 1 power, 2 power, 3 power. That's 6 powers. And my number in front is a negative number. So this is going to be f of x equals a negative x to the 6th power, blah, 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 if I multiplied it all together, which would be its own little nightmare. But what we need to know is that we have an even power and we have a negative number. So if we have an even power, our ends are going to be going in the same direction. If we have a negative number in front, it's going to be pointed down. I should have had some more odd ones. Okay, so this is going to be the limit of f of x as x moves to the left is negative infinity, and the limit of f of x as x moves to the right is still negative infinity. So let's see what we have here. Let's add up powers. Maybe this one will be odd. I don't know. 3, 7, 8, 9. It's still even. 14. You know what? Let's give it one more power. Let's do one more. Let's put one more factor in, just so we have an odd one. Okay. Let's say x minus 1 to to the third. Okay? Yeah. So there, we added that in. Just to add that in. I'll make that change to the worksheet you have. So 3, 7, 8, 9, 14, 15, 16, 17 powers. 17 powers, and the number out front is positive. So this is going to come out to be f of x equals 2x to the 17th, and yada, 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 yada. Nobody cares. So our powers, this is an odd number. This is a positive number. So because we have an odd number, odd powers are going to be different. Directions, different. And because, whoops, wrong color. This is even. Nope. This is positive. Positive is going to most take on this shape. And so that is headed downhill and then headed uphill. So that is the limit of f of x. As x moves to the left, it is also moving down. And the limit of f of x as x moves to the right is then headed up. So that is it, my friends. And that is all you have to do. So basically, this part of the problem does not change. The only thing that changes are what's going to go in those spaces. That's the only thing that changes. We always read graphs from left to right. So this graph will, this is going to be odd power. Let's go with color, Leonard. So odd power, positive lead. This is going to be odd power. Negative lead. These are both going the same way. So this will be even power. And they're both going to positive, so that will be positive lead. And this is also going to be even power because they're both going the same direction. Even power. This is going to be negative lead because they're both headed down. Their shapes are mostly going to look like this. This one will have a negative slope. This one will be pointed up. And this one will be pointed down. And there you have it, my friends. That is end behaviors. Have a great day. If you have any questions, ask me in class or send me an email.